Welcome to the Data Hall YouTube channel. In today's video, we are going to talk about data structures in R. So there are different types of data structures in R. And what are data structures? They are different ways of storing data. So in R, we have vectors, matrices, data frame, and list. And we would have a video on each of these types of data structures, and we would discuss them in detail. So in this video, we are going to start with vectors. Vectors in R. So what are vectors? Vectors is a list of different elements that would contain different data, but it can be visualized as a column of different observations or a row of different observations. But remember, it would contain exactly same data type. So a vector would have same data type. So in this case, this is a numeric vector because it contains all the numeric observations, and each observation would have an index number to access that observation. So in this case, this 55 is stored in, say, index 1. So, and 34 is stored in index 2. So this is the numbering of different, so say for example, data points in a vector. If we visualize that as a column, then again we would have indexing. So in some programming languages, the index would start with 0, and then we would have 1, 2, and 3, and so on and so on. But in R, we have the indexing starts with 1. We can have a character vector that would contain all the elements, all the data points would be character. So remember, vector would be a single dimensional object. So it would just be, one dimension. Whether you visualize it as a column or a row, it is neither a column nor a row, just different data points. In this case, it is a character vector. But let's just say if we put in 77 over here, which is a number, but if this vector is a character vector, then this would be represented as a character. So this 77 having these quotation marks is considered by R as a character rather than a number. So we cannot perform certain arithmetic operation on this. We can have also have a logical vector that would just contain true or false. And also remember, in R, the single digit or single alphabet or single word is also a vector. So vector doesn't, in R, it doesn't mean that it would have to be couple of observations, right? So let's move to R and see how do we work with vectors in R. Okay, so we have over here our R file, and this video is going to be about vectors. So we are going to discuss how do we create vector, how do we access different elements in a vector, how do we add or replace a value in a vector, apply different functions, and some other topics related to vector. Okay, so let's start with the basic idea. So let's say if we want to take this this number 5 and store it into an object, then the simplistic way is to store it, let's just say, in this object. This is the name that we have given to an object, and if we this sign is used to assign something, some element to an object. So we can see that in our environment we have this vec1 which contains this number 5. Now this vec1 is a vector. We can access whatever the value stored in this vector by selecting that name of the object and pressing Ctrl Enter. Similarly, let's just say we store this number 10 in vec2, and we can access that by pressing Ctrl Enter. Right? So we have these two vectors. Remember, a single number is also considered, or a single character is also considered a vector in R. We can have different numbers. So for example, in this case, we are using this concatenation or combination, and we are storing different numbers into this vector called num. So this is the name that we have assigned. You would have assigned any name that you want. If we press Ctrl Enter, then we would have this num vector over here, and we can see that we have 4 objects, 4 different elements, data points in them. And if we want to look into this vector, what do we have in this, then we can see that we have these numbers in them. Now this is a numerical vector because it just stores numbers. What about this vector? This contains different characters, and then there is a number, but this would be considered a character vector, right? So all the elements in a vector should have the same data points, right? So in this case, although it is a 9, but in R's way, R think of it as a character, as a string rather than a number. So you cannot perform any operation on this specific number, but you can do that on these because there isn't any inverted quotation marks or inverted commas with this 55, 22, etc. because according to R, these are numbers. So how do we access data from a vector? So we have this character vector and there are certain elements in them. We know there are 6 elements. If we wanted to get this 4th element, then what do? Is we write the name of the vector. Then within parentheses, within these brackets, we write the number of element that we want to access. So in this case, we want to access this 4th element, which happens to be this number 9. If we wanted to access multiple elements, let's just say if we want to access the 2nd element, which happens to be John, then the 3rd element XYZ, and then the 6th element. So the way to write is we give the name of the vector and within brackets we would combine these using a concatenation, right? So we get that elements. Similarly, we can access a range of elements from a vector. So we want the elements from number 4 till number 6. So that would be these 3 elements. Or we can give it a range and then specify a single element. So we want 3 to 5. So that would be this XYZ and these 3 elements, and then we would get this first element, which is ABC, right? We can also not get an element, so we can access every other thing but not a specific element from the data. So let's just say if we want to access all these elements from this vector character, so this is the name of the vector, except for this 3rd element. So we would specify it by with a minus prefix, and that would give us all the elements in this character vector except for the element that is on the 3rd number, which is XYZ. Or we can specify a list or a range of elements that we do not want to be included. Let's see how do we add or replace a value in a vector. Now what do we do is, let's just say there, let me get this vector over here so we can know what we are doing. So on the 2nd element, we have this name John, but we want to replace it with Alberto. So what do is we get the 2nd element. And how do we access the 2nd element? We have already specified over here. We write the name of the vector and then within brackets we specify the number or the index of that element. So we want to change the 2nd element, so we would specify that. So change the 2nd element of this character vector by this specific name or object or whatever element. So if we look at our vector, so the name John had been replaced with Alberto. Similarly, if we wanted to change the 7th element, now we know it is this vector contains 6 elements. What if we wanted to change the 7th element? We know that it doesn't exist. So what it would do, it would just create that index and assign the value to it. So we know that there was nothing after the 6th element, that was an empty space, so it added that. So you can add a value to a vector by that way. Now we know that there are 7 elements. What if we wanted to add an element at the position 10th? What would happen at element say 8 and 9, at the index 8 and 9? There are no data points there. So let's just say if we add that, and look at the vector, you would see that there is an NA. Now this NA is not a character or a string because there is no quotation marks around it. It is just the R's way of presenting the missing values. So these values are missing. So this 8th and 9th are missing, and you can see that we can get an idea of where which number of object this is, because this is the first object, and then we would have 2nd, 3rd, and 7th, and then we would have 8th object, 9th, and 10th. We can apply different functions to a vector. So if we wanted to check this character object over here in our environment is a vector or is it a matrix, we can use this is.vector function to check, and it would return either true or false value, and it says true, that means it is a vector. Whether it is a numeric vector or not, so we use is numeric and then the name of the vector, so we know that it is not numeric. It is a character vector, so we can check that whether it is a character vector or not, and that is true. We can get the length of the vector, and we know that there are 10 elements in them. And if we wanted to, we had these two vectors, vec1 and vec2, and we can see whether this vec1 is greater than vec2 or not, because vec1 contains 5 and vec2 contains 10, and that would give us a true or false value. Whether vec1 is greater than 3, we can specify a specific element, a specific number, and that would represent the true or false. Now let's understand what vectorization is. Now in R, this vectorization is a quite powerful concept, and this concept doesn't apply in many programming languages. So there are a couple of programming languages that use vectorization, but vectorization is quite powerful. And what vectorization is that, let's just say we have this vector 1 that contains number 1, 2, 3, 4, 5, 6, and then we have vector 2 which contains 7 till 12 numbers, right? And we want to add these numbers. What R would do is it would take the first element of this vector 1, v1, add it to this first element of vector 2, that would be 8, then take the second element of the vector 1, add it to the second element of vector 2, that would be 10. So go so on and so forth. So if there was no vectorization, then what would you have to do is you would have to loop through each row of these numbers, or through each element. What if you had a smaller vector? Let's just say this vector 1 was or contained 6 numbers, but what if vector 2 contains only say 4 numbers? Then what R would do is R would replicate this vector, right? So there are 4 elements. So what it would do is, once we have reached, we have consumed this whole vector, it would take this 7 and 8 and paste it over here. So this, if we wanted to perform certain operations, because we cannot perform operations on a vector of different sizes, so we'd have to have the same size vector. So it would replicate the smaller vector to the point that it reaches the same length as of the larger vector. So that way we would have the 7 replicated and the 8 replicated over here. Now let's look at that concept in R. We have this first vector that contains 6 numbers, and then we have the second vector that contains 7 till 11. If we wanted to add v1 and v2 vector and store it in v3, then we would get these numbers. That would be the first element of first vector plus this first element of the second vector, first element of second element of the first vector, and the second element of the second vector, and so on and so forth. So 12 plus 6 would be 18. If we wanted to perform this operation, say we decrease the size of this vector. Now this v1 is of 6 length, but v2 is of length 4. Now if we wanted to add them, we have this v1 and v2, right? So this is v1, and let me just get them into console so we can see what's happening. And now let's add v1 and 2. The first thing it would do is it would give us a warning. Now remember, this is a warning and not an error. An error would stop execution of that line, but a warning would perform the task, but not but just give us the warning. So what the warning says is that the shorter the length of the object basically doesn't match. So if we look at v3, then it what happens is that the v1 was of 6 length and v2 was of length 4. So it took the first element, added to 7, we get 8, so on and so forth, till we reach the fourth element, which is number 4, added to 10, we get 14. What about after that? Because we have consumed v2, but we have 2 elements in v1. So what it would do is it would take this fifth element of the first vector and add it to the first element. So it would try to replicate this, recycle this shorter vector. And remember, you would only get this value if the multiple of 2 vectors isn't match. So for example, if you had, let's just say 9, so let's just say if you had 3 elements in vector 2 and 6 elements, so they both are multiples of one another. So that way you wouldn't get a warning. So that is something you should be aware of. You cannot perform arithmetic operations obviously on a numerical and a character vector. So if you do that, it will throw in an error. And we can also use sequence and repetition. So what sequence is that if we want to generate a vector that contains number 1 to 5, so we can simply write 1 to 5 and assign it to an object. Or we can use that using this sequence function, seq function. And within seq function, we just specify the first element and the last element that we want to have. So this would generate a vector that would contain 1 to 5. So this is similar to using a colon. So whether you use sequence or colon, that is exactly same, and you can look at the results. They generate exactly same results. The only difference is that sequence do have an additional argument in it. So whenever we write a function, there is an argument. So we just wrote 1, 5, but we could have written it more clearly. So this 1 is from 1 to 17 or to 5, but then there is this third argument, which is by, and by means that we want to increment the numbers by 3. So we take first, increment it by 3, we get 4, increment it by 3, we get 7, till we have consumed all the values and we cannot go beyond 17. And this by is not available with this colon version of generating a sequence. So the shorter version of the same command could have been this. So instead of writing the whole argument, we could have written it like this, and that would generate exactly same. Then we have rep, which stands for repetition. And what it would do is it would take the element or a vector and repeat it multiple times. So we want this word, the data hall, to be repeated 4 times, and that would be generated. Or we can do that with the number, right? So take 1, repeat it 4 times. Or we can get a vector. So this is a vector that contains 2 elements, that is car and bus, and it is stored in this object called vect, and we can repeat this 5 times. So we take this vector and repeat it 5 times. Or this is exactly similar to getting this whole thing and pasting it instead of this name of the vector. So that is exactly same as above. Lastly, we can generate random numbers in vectors. So we use run if, and we just specify the number of elements that we want in the vector. We want 44 elements, but we can also specify, in addition to the number of elements that we want, we can specify the minimum and the maximum value of these random numbers. and we would have a minimum of 22 and a maximum of 77. So I hope that was useful. In our next video, we are going to discuss how do we work with matrices. So thanks for watching this video. Do subscribe and do hit the bell icon.